resistive circuit. How do I know? How do I know that current is common in series? Just by looking at it. How do we know?
There's only one path.
Yes. One path for current. So we take our little lazy electrons. Hey, there is only one path. So each resistive value, or each resistor, has no choice but to feel the brunt of that one common current, correct?
Yes, sir.
Therefore, knowing Ohm's law like we do, we know that each resistor is going to drop its own voltage, a drop from the rise, which is known as a source. And we can take that information, apply Ohm's law, and calculate parameters in the circuit. Notice that I have test points, because we have to look at that one more time to make sure we know what's going on with that. What does Gustav Kirchhoff say about voltage in a series circuit? Okay, sum of voltage drops, in a nutshell, equal source. That's an easy way of looking at it. That is, VR1 plus VR2 plus VR3 should equal applied voltage or source. Yes. That's the easy definition. Or the algebraic sum of the voltage drops, the voltage rise equals 0. Same thing. So we don't have to worry about algebraically. Isn't it the same thing as just adding the voltage drops, and if they equal source, we know we did it right? It's the same thing, basically. So I'm going to go ahead and we're going to do a little practice. I'm going to solve this circuit. Can't have enough practice. No such thing as that. 10 volts, 5K, 10K, 3K. Solve the parameters. Since we know that total resistance in a series circuit is additive, probably just add these together. 10 plus 3 plus 5 must be how many? Huh? 18 what? Flying pigs? 18K ohms. That's amazing. Just the bare minimum in solving these circuits. Ohm's law, power applied, know the rules. That's all you got to have up in your brain housing. Now we can find total currents because we have two of the three. We've got total source and total opposition. We can find total current now. Ohm's law is over there. 10 divided by 18K gives me what?
556 milliamps.
555.56 micro?
Yes, sir.
Microamps. Easy stuff. You got to do this kind of stuff on the test. It should be nothing but a thing now. We've had lots of practice. Once we have the total current, we know that, hey, it's common. That's the rule. We can take that common current and use Ohm's law and multiply by each resistor respectively to get each voltage drop respectively. So 555.56 micro times R1 by K. VR1 equals our 2.78 volts. All right. And we can do the same thing to VR2 and VR3. Easy day. What be that answer, Mr. Tripp? VR2. Oh, we need to be like doing it and stuff. If I'm going too fast, let me know. No, you're not, Mr. Tripp. Wait on Tripp. Well, some didn't ask questions on the PX. You don't know how to do this stuff by now. You better be asking questions.
5.55 volts.
Mr. Tripp says 5.55 volts. Nobody's grumbling, must be. VR3. Same deal. I total times R3. What's that, Mr. Goss?
1.67 volts.
1.67 volts. All right, then. How do we know that we did that correctly? Church off that trash. So 2.7 equals 5.55 was 1.67. Should be pretty dang on close to 10 volts. Is it? Yes. All right. Now, you may be called upon to determine, hey, solving the circuit's good. Got it. But what's the voltage drop from point A to point C in this thing? But what's the rule about the subscripts? The red lead always goes where? First subscript, point A. Pretend this is black. The second subscript's the black lead. So from point A to point C in the circuit, that covers VR1 and VR2, doesn't it? Yes, so what is the voltage from point A to point C?
8.33 volts.
And we have to add these together because that's what it covers. All right. How about the voltage drop from point B to D? Red subscript, first lead, or red lead first subscript. D down here, isn't that VR2 and VR3? Across both components. What's the answer?
7.23 volts.
7.23 volts. You're just adding VR2 and VR3 together because voltage is additive in series. Holy crap. Voltage from point A to D. Here. You need to do anything for that? If you realize A to D, holy cow, top of R1 and the bottom of R3 is in parallel with the source, so it must be 10. That's amazing. And what about point C to B? There you go. Red, point C, first subscript, and then B. It's just VR2, but because of polarity, it must be a negative 5.55 volts and stuff. Is that tough? Series circuit, jeez. You need to be able to do all that. Here's the question of the day, though. If I decide to add resistance to this thing, or I'm adding another resistor at the bottom and calling it R4, and I don't change the source, I leave the source alone, and I add resistance, what's that going to do to circuit current? Because we know the relationship between resistance and current is what? The inverse. If resistance increases, current has to decrease. Does that make sense?
Yes, sir.
Relationship. And obviously, if I take one of these resistors away, I have less opposition, so therefore it's probably more current to circuit, right? Less opposition, more current. Good. Questions on series.